Thanks very much for the very kind introduction, and thanks for the invitation to speak here. This is my second time here in Abu Dhabi, but the first time I was here a couple of years ago was just a very short visit. I think I was here for about 24 hours. This time I'll be here for a week, and so I'll have a much better opportunity to meet people here and meet some of the institutions. I'll be giving some talks at some of the local universities as well. And so it's a great pleasure to be able to see a little bit more of Abu Dhabi. So what I want to talk about is a little in general about causality, about experimentation, kind of the role of experimentation in the digital world, and in particular in relation to AI and some of the research in economics on the value of AI in the current world. So I'll kind of talk briefly about what my perspective is, what I mean by causality, and then I'll talk for a while about randomized experiments, and kind of start off there talking about what is special about experiments, and I'll discuss some interesting experiments that have been done in recent years, and why they're interesting. Some of them actually AI related, some of them kind of in general about the role of technology in various places. Then I'll talk a little bit about some of my current research about complex experimentation. Experimentation has changed substantially since the 1920s, when researchers like R.A. Fisher and Neyman kind of developed the theory of randomized experiments and the role of experimentation. The current applications are often in digital settings where there's interesting complications that call for the more complex experimental designs. Then I'll talk about some recent paper that actually kind of tries to see if AI can make experimentation superfluous, whether AI can play the role of experiments, and I'll talk about the value of AI. So first about causality. What do we really mean? And here there's kind of a number of statements I put up there that at some level or another make claims about causality. And kind of the first one is really the example I start off with typically in the classes I teach on causality. If you talk about the effect of taking aspirin on a headache, what we really mean is that at a particular point I may have a headache, and I can either take an aspirin or not take an aspirin. And what we're interested in is what the difference is, what the outcome would be, what the state of my headache would be if I actually took the aspirin relative to not taking the aspirin. I can't really see both. I can't do both at the same time, so I can't directly make that comparison, but I can at least think about that, and that is the object I'm trying to get at. I'm trying to get at the effect on some outcome of a particular intervention, of a particular manipulation, and being clear about what that effect is, and what that intervention is key in understanding what the causal effects are we're interested in. And so similarly, kind of I teach at the Graduate School of Business at Stanford, when we have executive education classes, you can think about what the effect of enrolling in a program of executive education, what that does for outcomes for the participants, and exactly what the mechanism is not clear. It may be what we teach in these classes, it may be the networking opportunities, but we can think of a state of the world where these people did enroll in these classes, and some outcome materializes, or they didn't enroll in these programs. And something else would have happened, and we're interested in the comparison between the two. Similarly, we can think about a world in which there are particular AI capabilities, and that may change productivity relative to what would have happened had we not had those capabilities. And kind of the nice thing about these first three statements is that we can often think about, we can at least do thought experiments about what a particular randomized experiment would look like that would tell us what these effects are. We could take some of the people who apply to these executive education classes, and we can randomly accept some of the applicants, but not others, and see what outcomes are for those individuals. That's not quite so clear for the fourth statement, and this is something where there's actually the literature in economics that has looked at the effect of particular individual characteristics on earnings, things like trying to get at the effect of height on earnings, where there is quite a substantial, quite a precisely measured correlation between height and other physical characteristics and earnings, but it's not quite clear what is really meant by that. If there is a correlation there, it doesn't mean that if we have people wear the platform shoes, that somehow their earnings would go up. It may well be that the effect there is something about nutrition in early childhood, and maybe other effects. It doesn't mean that giving someone growth hormones at a particular point in time would actually increase their earnings. And so the key thing is that we want to be clear about what the intervention is in order to think clearly about the causal effect. One of the examples I'll also look at is the effect of working from home, where of course there's a lot of discussion in modern economics about what the effect would be of allowing people to work from home in various settings, especially since the pandemic. There's a lot of studies suggesting that there may be good things about it, there may be bad things, but it's clear that changing the rules there may change productivity in a way that is going to be very important to study, and that's going to interact with the availability of new technologies. And more generally, I'll talk a little bit about the role of technology in the educational sector and how that affects learning. And here I'll actually look at a randomized experiment that also I'm teaching this class at the moment for undergraduates at Stanford, where we study causality and experimental design, and we look at these studies to see what the effect of technology is on classroom learning. But so let me talk a little bit in general about randomized experiments, and I'm going to try to leave enough time for questions, because I really would be very happy to take questions about all these topics. But randomized experiments really go back to the modern study of randomized experiments, goes back to the 1920s and 1930s with people like Fisher and Neyman, where the setting often was agricultural experiments where they were interested in the causal effects of different types of fertilizer. And so here you see a picture of the Rothamsted Agricultural Research Station, where the way they would do these experiments is they would take a big piece of land, divide it into subplots, and put some fertilizer on some of the plots and other fertilizer on other plots, wait till the end of the season, and then see what the yield was in these different plots. Now, of course, that turned out to be an incredibly successful strategy for really learning about causal effect, and it really became the gold standard for studying causal effects, to the extent that in medical settings, the Congress in the United States mandated that as part of the drug approval process, drug companies needed to run randomized experiments to study the effect, to make sure there was clarity on what the causal effect is. We don't allow drug companies to just market drugs based on their sense that these drugs are effective, that these help with particular medical conditions. We want to have carefully randomized studies where there's a whole protocol about how these studies need to be conducted in order to provide clear evidence. Now, for a long time, that was the setting where most of the experiments were done. Nowadays, that's really shifted quite dramatically in the last 20 years or so. Almost all the experiments, the large majority of the experiments, are done online by the tech companies. places, the companies like Google, Facebook, Apple constantly do experiments to figure out how to make their services, to improve their services, to improve the things they expose people to, in order to optimize the experiments for the users, and we'll kind of look at some of these experiments, and the fact that the experiments there are being used, it sort of leads to some different questions. It leads to new questions about experimental design, but also really focuses on different decisions. In the end, it's about it's much more about experimentation as a process to improve the services, rather than about studying scientific questions whether one particular intervention has some causal effect. In these online settings, often the effects change over time, and so it's really much more about a process where you're trying to continually improve the decision-making process. Now, kind of before looking at some of the specific experiments, I want to kind of make a couple of points about why experiments really are special. And so I'll give a couple of quotes. Here's one from David Friedman, who's a statistician at Berkeley, where in a paper he writes in the abstract that experiments offer more reliable evidence on causation than observational studies. And that's a statement I completely agree with, and that partly refers to the gold standard perspective on experiments. By controlling the assignment process, we make sure that there's no systematic differences between two groups. Kind of if we're looking at the effect of a particular binary intervention, say taking aspirin or not, by randomly assigning people to the treatment and control group, we ensure that even though there may be some differences, there's no systematic differences between the treatment and the control group. And we can, with great confidence in a large enough experiment, we can attribute with great confidence differences we see between these two groups to the intervention, to the particular treatment that the treatment group was exposed to. Whereas in an observational study, we're never really quite sure. We may do the study very carefully, and there have been great advances in the literature on how to do observational studies, because most of the data are in the end observational, and experiments are often very expensive. But when we can do them, experiments really are very special in that they give us much more credible estimates of causal effects. Now, at some level, that may seem fairly uncontroversial, even though even in medical settings, there's concern about randomized experiments, and there's often ethical issues. We're not about to kind of change the rules there that we would allow drug companies to market things without doing randomized experiments. But I do want to actually stress that in parts of the literature, there is still some disagreement with that. And here's a quote from a paper by Angus Deaton, who won the Nobel Prize in Economics in 2014 or so, where he writes that experiments have no special ability to produce more credible knowledge than other methods. So that actually seems to be quite in contrast with the Friedman quote, where Friedman sort of unambiguously argues that the experiments are better. Deaton kind of raises a bunch of concerns with randomized experiments, and some of them I agree with. There's often concerns that we may do experiments in very special settings, that the populations may not be representative of the populations we're ultimately interested in for applying the results. There's concerns about external validity, and we've seen that in practice even in medical cases. But it doesn't take away from the fact that when we can do them, when we can do carefully randomized experiments, we do get better evidence on causal effects than from any observational study methods. Observational study methods are always going to be second best in terms of allowing us to make credible and precise causal claims. And kind of in a paper, here's a quote from Wikipedia, kind of that we shouldn't necessarily always trust what Nobel laureates say. And so in this case, I think Deaton is wrong in this particular quote. And that randomized experiments really are very special, that they do give us better evidence on causal effects than any other methods. So now, kind of make a couple of comments on what's happening in experimentation now. Most of the experiments now are done online. There's a study that kind of shows that the tech companies collectively now do hundreds of thousands of experiments every year to optimize their services. And again, these experiments are not quite the same as in medical settings. They're less about finding the truth than about building a process that helps make better decisions. And one of the interesting things of this shift in settings is that there's been a lot of interest in doing more complex experiments. Often we now do experiments adaptively, where the units coming into the experiment come in sequentially. And so rather than having a fixed fraction assigned to treatment and control groups or to various control groups, we adaptively change the assignment in a way that takes account of the information about the treatments that we accumulate during the experiments. And that leads to much more efficient experimentation, especially in settings where we're trying to figure out the best treatment among a large set of potential treatments. Other complications that arise from these online settings is that in many cases we're very concerned about spillovers, interactions, or equilibrium effects. Kind of think about a setting such as Uber, where we may want to evaluate a new policy changing the experience for the drivers. We may make it more attractive for drivers to ride. We may change the surge pricing or discounts or whatever. But if we do something where we change the experience for some of the drivers and we make it more attractive to be driving at a particular point in time, that immediately affects all the drivers in the entire market. It affects also the drivers in the control group. Because as soon as for one driver it's more attractive to be driving, to be offering their services, it means that they affect the riders in that market. They're going to be increasing the competition for the riders. And so as a result, they make the experience worse for the drivers in the control group, and they may be less inclined to be driving at that particular time. And so simple comparisons between drivers in the treatment group and the control group is no longer going to tell you what the average effect is of implementing that intervention. Whereas that simple difference in comparisons of average outcomes is exactly the thing you want in a medical trial. If you're looking at the effect of aspirin on headaches, that's no longer going to work in these marketplaces where you have different populations interacting in complex ways, often anonymously, but kind of in complex ways that would require some economic modeling, some modeling of the equilibrium processes. And that is because that's not just true for Uber, that's true for all these online settings, kind of where the very fact that individuals interact is often the basis for these platforms and for the services they provide. So that's kind of generated this huge amount of interest in trying to come up with experimental designs that can actually answer questions about causality in these settings where there's systematic interactions and spillovers, in particular in marketplaces. And again, kind of these experiments are often not so much designed to find one particular parameter, one particular causal effect. They're focused on trying to help decision makers make better decisions systematically over time, whether that's in medical settings or in economic, in business settings. It's all about improving decision-making processes systematically, where doing experimentation is viewed as just like any other investment. You're investing in the amount of information, the optimal amount of information you need for making good decisions. So let me go through some examples of experiments that have been impactful or interesting in particular ways. And so one that was kind of impactful in economics was an experiment that was done at eBay, I think about 10, 15 years ago, 10, 12 years ago. At that time, eBay was doing a huge amount of advertising, and kind of it nicely illustrates kind of the importance and the usefulness of doing careful experimentation. At that time, eBay was doing a lot of advertising on Google. So if you were to go to Google and you typed in eBay, you would see, the first thing you would see is an advertisement for eBay. And that turned out to be incredibly useful to have that advertisement on there. Lots of people would click on that and drive traffic to eBay. And so internally, eBay viewed that advertising as incredibly successful, because they were getting a huge number of clicks coming through the people clicking on the advertisement. And they built economic models that suggested this was an incredibly valuable way of advertising. Because if you look further down the page, if you search for eBay on Google, the next item after the advertisement for eBay would just be the generic search result for eBay, which was the same, would get you to the same website, but not based on an ad, but on the organic search result. And so the fact that people clicked on the advertisement wasn't actually answering the relevant question. The relevant question was, had they not advertised, would they have had fewer people going to eBay? Because most of the people searching for eBay wanted to go there, and had the advertisement not been there, they would have just clicked on the next item, on the generic, on the organic search result, and they would have still gotten to eBay. So some of the economists at eBay convinced the company to do this experiment where they would shut off the advertising in some regions but not in others, and at different points in time, to see if these models that some people had developed there that suggested the advertising was very valuable, whether they actually were getting at the right causal effect. And it turned out that if you were to shut off the advertising on Google, the number of clicks coming through the advertising would go down to zero. Because you could no longer click on the advertisement because it wasn't there anymore. But the clicks on the organic search query, on the organic answer, would just go up by pretty much the same amount as the clicks on the advertising had gone down. Because people still wanted to go to eBay. They just now went there in a slightly different way, and it wasn't less convenient because it was now the top item on the search page. So it turned out there really wasn't any value to the advertising there for them, because the causal effect of dropping the advertising was essentially zero in terms of the traffic that would go to eBay. And so here, kind of again, that just illustrates that being careful about what the causal question is you're interested in is very important to get to the right answer. Now, kind of here is another experiment where at Uber, they exploited the fact that because people have the Uber app open on their phones when they're driving, they could give drivers feedback on the quality of their driving, because the phone can actually record kind of how fast the car goes, kind of how suddenly it stops, how fast it accelerates. So there's things you can use from the phone to measure the quality of the driving. And it turned out that the intervention here was curating some of that information and giving that back to the drivers, giving them feedback on the quality of their driving, kind of the sort of general evidence that Uber drivers are actually better than the other drivers because they have more experience. But here the question was whether you could improve the quality of their driving by giving them feedback directly from their driving. And it turned out that on average they didn't actually do very much, but for the drivers at the lower range of the quality of driving before, giving them that feedback did actually matter. Giving them the feedback on the quality of their driving improved their driving subsequently. And so here the point I want to illustrate is that often looking at these cause effects, you need to be very careful. There's often a huge amount of heterogeneity in exactly where these things matter, and just looking at overall effects and at generic policies is not going to be helpful. And this is true nowadays, kind of in all the discussions on personalized medicine, that the heterogeneity is hugely important. And here, the particular heterogeneity that mattered was that it was the relatively low-quality drivers that benefited a huge amount from getting information on the quality of their driving. Another very interesting recent experiment was about using AI to enhance productivity of workers. And so here the setting was in a call center. And so having AI available there made it easier for the workers in the call center to access information about how previous queries of similar type had been answered, what were effective strategies of dealing with particular queries. And so this is one of these examples where it's AI not replacing workers as much as enhancing their productivity at making them more effective at doing the tasks they were doing. And so what you see there, so the top graph is kind of one of the key ones. You see that having the AI enhancement for the workers increased the number of resolutions of calls per period. It made them faster at getting to the resolution without, and you can see that in the bottom right, without changing the customer satisfaction per call. So here, what it did was allow, and looking at heterogeneity, you see that again, it's in particular the low-quality workers, the inexperienced workers, were getting better very fast at answering calls at the same rate, at the same satisfaction rate as they did without the AI, but just doing it faster over time. And so here are some more graphs. You kind of see that there's no evidence of any effect on the customer satisfaction per calls, but the time it took workers in the call center to come to a resolution to handle a call improved substantially. You can see that in the average time will go down, or the number of calls per hour would go down. So would go up. Here's an experiment about working from home. So here there was a very large experiment done at a travel company in China, and the question was, what would allowing the workers from home do for both the productivity, was there heterogeneity in which workers benefited or were negatively impacted by working from home, and what outcomes were actually useful to measure here. What you see here is that overall there was a benefit in allowing work from home, that it greatly reduced attrition for the workers who were allowed to work from home. These were people who often had substantial commute times, and so it improved the overall experience for these workers. Turned out there was a fair amount of heterogeneity, that it particularly improved the experience for the women. They were much less likely to drop out of, to resign from the company relative to the men. And there's some evidence that this was particularly related to the commute time. Now, of course, the question was, it may have improved attrition rates, but did it impact other aspects of the work? And there turned out to be very little evidence of impact on the performance of these workers. There was no evidence that they were less productive or that somehow their performance was adversely affected by allowing them to work from home. And you can see that sort of in the performance. You can see that in the promotions and other measures of overall productivity. Next example, and that's a particularly interesting one about using AI. So this was at an economics consulting company, Boston Consulting Group. The question was how AI tools there help the business consultants. And again, it's the heterogeneity that is particularly interesting to see here. And the heterogeneity that was the most interesting was the type of tasks to look at for AI. And it was divided into tasks that were relatively easy, that were inside the frontier, where there was a lot of evidence about what the right thing to do was, versus tasks that were outside the frontier, things that were actually very difficult. And it turned out there was a lot of heterogeneity there. So for tasks inside the frontier, the performance was greatly improved by giving the consultants access to AI tools. You see it here quite striking, and so there were sort of two versions of the treatment, the ChatGPT only versus ChatGPT with some additional enhancement that didn't really make all that much of a difference, but it was strikingly better in terms of the quality of the work that these consultants did relatively to not having access to ChatGPT for this particular type of task. You get the graph here really just illustrates that very clearly. Kind of the statistical analysis kind of similarly shows that having access to these tools greatly improved the performance of these consultants. But what was remarkable is that if you looked at tasks that were outside the frontier, things were very different. For tasks outside the frontier, the effect of the quality of the work was not actually just zero, it was in fact negative. The consultants in some sense were lulled into a false sense of security there, that they took these answers from ChatGPT at face value and then ended up actually doing worse in terms of the quality of the work than the consultants who are not using ChatGPT, were not using these tools. So at some level, this may give us a sense of comfort that may be a little misleading in the long run. It may be that ChatGPT and these other large language models are getting better fast enough that soon everything will be in the frontier, and that there's no concern about these tasks outside the frontier. But at least at that time, it still seemed that for things that were relatively novel, that are outside the frontier of what was easy to put inside an algorithm, the large language models were not doing well in terms of the quality of the work. And again, these were fairly precisely estimated. This was over a large number of tasks, and so it was very clear that in contrast to the tasks inside the frontier, for tasks outside the frontier, AI wasn't helping much, and in fact was hurting the performance. Can I hear one more example? This is actually one I used in the undergraduate class that I'm teaching this quarter at Stanford. Here there was an experiment that was done at West Point, actually, at one of the military academies in the US. And the question was whether allowing students to use technology in a classroom setting would actually help their performance. And so the setting was a particular class that was required, and so there were a bunch of different sessions. The sessions were randomized to allow the use of laptops. So it wasn't that students were forced to use anything. In some classes, students were not allowed to bring laptops to the classroom. In other classes, they were allowed to use them for taking notes, for doing other things. And concern, of course, is, as anybody who's taught knows very well, once you allow laptops in a classroom, the students may be doing other things that they're not supposed to do. And so here, this was a very nice setting where there was a common exam at the end. There were multiple sessions of the same classroom, so they were getting exactly the same experience with the same teachers, but the only difference that they were restricted in some classes and not in others. And so what you see is that there was a substantial decrease in the performance of the students. So here there were two versions. One case, in the case where the students were unrestricted, had no restrictions on using laptops, the performance went down by 0.18 of a standard deviation of the test. And even in cases where it was just a modified tablet only, it went down by about the same fraction. So there was very clear the evidence that allowing the use of technology here, allowing the use of technology greatly substantially hurt the performance of the students. And so this is actually the reason why in this class I was teaching together with a computer science professor. We were not allowing the use of laptops, and we had a long discussion kind of about whether this type of evidence is actually relevant. Obviously, these students, this was at West Point, these students are different, the class was different, and so there's all sorts of issues with external validity here, but it does show that at least in some cases, the use of technology isn't an unambiguously good thing here. In this case, it really hurt the performance of the students. The other very interesting finding in this study was there was a lot of heterogeneity in the effect in this negative effect on performance. And actually, the most interesting form of the heterogeneity was by gender. It turned out that in the end for the women, and that's actually a relatively small group here, this is West Point, for the women it made no difference. In fact, it's sort of the slight positive estimate, but it's very imprecise. It's basically zero. So for the women, there was no effect of allowing the use of laptops in the classroom. The effect was all coming from the men doing worse on the exams if they were allowed laptops. There's some evidence that the effect was much bigger for the better students. So that the better students were more, if we think of this as coming through being distracted, that the better students were more distracted by having the laptops in the classroom, and so the effect was much bigger for them than for the relatively weaker students. Kind of again within the context of this being West Point, where the students generally are very well prepared and have very high AC prior test scores. But again, the effect seemed to be bigger for the better students. But the main heterogeneity is that it's all for the men rather than for the women. Last example. So here's some results from an experiment on search algorithms. And so the question there is sort of how the ranking affects click behavior. Obviously, in general, if you put if you run a search query, the algorithm gets a bunch of answers. If it puts an answer higher up, it's more likely to get clicked on than if you put it lower. And so this is based on an experiment using Bing. And so in general, moving something that in principle is the top item, moving that from the first spot to the fifth spot leads to about a 13% drop in clicks. But what is interesting here is that effect has a great deal of heterogeneity depending on the type of query it is. These things matter very little if you're searching for something where you kind of know what the answer is you're looking for. If you're looking for, say, a picture of a particular celebrity, it doesn't actually matter whether you put that in the fifth spot or the first spot. You kind of know what you're looking for and you're going to click on that. Where it matters is if you're actually looking for an informational query, if you don't actually know what you're looking for. If you're asking for what is the best book on this particular topic, what you put in the first item is much more important than what you put in the fifth item. When you're actually relying on the search algorithm to give you information on the quality of the things. And so again, this greatly matters for how we think about these search algorithms and the market power they have and how we think about what they should be doing. They do have a huge amount of power in terms of informational queries, how we're learning about things we don't know. Now let me switch kind of to some of the current literature on experimentation. And so here I want to look at the setting that comes up in a lot of these marketplaces where we may have two populations that interact with each other. So at a place like Amazon, there would be customers and products. At Netflix, there would be movies and viewers. At Airbnb or VRBO, there would be properties and renters. At rideshare companies, there would be drivers and riders. Or in some cases, it could be units and time periods. And the key features of the setting are that you can assign the intervention, and there may be giving some information, there may be something, but whatever it is, it's something that can be assigned at the level of the pair, viewer, movie, or customer, product, or the driver and rider. And so this is where the fact that these are online experiments is very important. If I go to a supermarket, I can't change the experience for one person relative to another person coming in at the same time. They would see the same displays, they would see the same products, they would see the same information, they would see the same prices. But online, we can change the experiments. If two people go to Airbnb at the same time and look at the same property, we can give some of them much more information about the property. We can show them videos, more pictures, relative to the other person who may get much less information or different reviews. And so we can change the experience there at the level of the pair, the property and renters or movies and viewers. And the same thing, we're looking at a setting where the outcome can be measured at the level of that pair. So we can see whether a particular individual rents a particular property or not, or whether a particular driver offers a ride to a particular rider. So we can measure outcomes and assignments both at the level of the pair from these two populations. And so what that implies is that we can kind of think of the experimental design as in the assignment as a matrix instead of a vector. Instead of just assigning drivers to a particular experience or not, or assigning riders to a particular experience or not, we can think of the assignment as being at the level of the pair driver-rider or movie viewer. And so the standard experiment is just a special case of that, where we have all the rows of that matrix the same, all the columns of that matrix the same. But now, in principle, we can allow for more complex interactions where we select some drivers, some riders, or some movies and viewers to be in the treatment group, but not others. And the key benefit of these more complex designs is that now we can learn about not just the direct effects of the intervention, but we can learn about the spillovers and the interactions of these interventions. And in many of these cases, we would expect those interactions to be very salient and of the essence, really. If we make some products more attractive to customers, they may not buy more products overall. They may be switching from control products to treated products in particular ways. Now let me skip a couple of slides because I want to make sure I get to the other things and leave some time for questions. But so you can take these multiple randomizations designs further, where you can actually assign some viewers to a movie experiment, some viewers to a viewer experiment, and you can get these very complex patterns that allow you to learn much more detailed questions about the spillovers and the interactions between the different parts of these two populations. And this type of experiments are now done at many of these marketplace companies. Now, let me then switch topics and talk about the last kind of two things. One is what is the role of AI in experimentation here? And one very interesting suggestion that has been studied recently is whether AI can actually make some of the experimentation superfluous. Can we use AI to actually predict what experiments are going to do? And we can do that in different ways. One is you could train these large language models on a whole set of experiments and just try to see what features of these experiments lead to particular causal effects and predict things from there. But an alternative way of doing it, and a very interesting way, is to directly use the AI to predict outcomes for units with particular characteristics, to actually take a population of interest and ask the AI to see what particular individuals would do in particular conditions, and then essentially have the AI run the experiment indirectly by predicting the behavior of individuals in different circumstances and then averaging differences in responses. And so a recent study actually did this for a bunch of social science experiments. This was kind of a particular type of experiments. These were often text-based, kind of nudge-type behavioral economics experiments where they asked people to respond to particular sets of prompts, and they changed them, and often this is in the form of giving them default choices and changing the way the defaults were presented. But what was interesting is that comparing the results from the experimental evaluations to the AI predicted effects was actually incredibly high. Here was on the order of 0.87. Now, these are, of course, very particular experiments, and one of the things that shows how special these experiments were, that here the predicted effects from experts were actually similarly accurate. The correlation between expert predictions and the actual experimental effects were also on the order of 0.8. So the AI was doing very well, but it wasn't necessarily doing better than the experts. And of course, experimentation is most interesting in settings where the experts don't know the answers either. It's exactly when we don't know what the answers are going to be when we need to do experimentation. And so I think there's work ongoing at the moment where they're trying to look at things exactly in settings where the experts don't do very well either, to see if AI can be helpful there in predicting experiments, or at least in giving us priors that allow us to do the experimentation in more effective ways. Now, for the last slide, let me actually give a quote here from Daron Acemoglu, who most recently won the Nobel Prize in Economics. He wrote this very interesting paper in May of this year, where he argued that at least in the medium term, reasonably long term, over 10 years, he argues that the effect of AI on the economy, on GDP, is going to be still relatively modest. And kind of the argument there was based essentially kind of on decomposing what people do into things that are easily affected by AI. And so kind of those are of the type like the call center experiment that I talked about. There's a bunch of tasks where AI is going to be very directly helpful and where it's going to have a huge impact. But that's still a relatively small part of what GDP is based on. There's a huge number of tasks that that at the moment at least are not directly affected by AI. When you're actually building a house or when you're doing construction, AI is not going to take that over at least in the short run. And based on that, on calculations of that type, he argues that in the end AI is still going to only have a relatively modest impact on overall GDP. Because the question is how long it's going to take for AI to become more impactful for these other tasks. I think the part where he's certainly right is that for a bunch of the tasks, the impact is going to be immediate and substantial, but the question really is how long it's going to take to affect the other tasks that at the moment we can't see directly how AI is going to impact them, but that are probably going to be changed in a way that the slightly longer term impact is going to be very, very big. So let me pause here to make sure that there's some time for questions. Thanks.
Thank you so much, Professor, for the fascinating presentation. We have 5 minutes for questions.
Thank you very much, Simon and Abdullah, for putting this together. And to Guido, thank you very much for coming. I think your work has been very instrumental for those of us in Amazon. Your work with Susan Athey as well, and the surrogate model has been very instrumental for us. I think my question will have to do with two things. The very first one has to do with the heterogeneous treatment effect that you mentioned, I believe, on page 12. In some instances, the definition of heterogeneity becomes a bit of a problem. It's not as discrete as you might want it to be, whether you're a prime customer or you're not a prime customer. In the case of the Uber example that you gave, essentially we are talking about bad drivers. In that case, I'm looking at it in terms of when someone is to define that heterogeneity on a continuous spectrum, do you see an issue with that? I can just look at where the treatment effect will be good, and I just go like, this is where I pick my heterogeneity from. My second question will have to do with the whole idea of conditional independence assumption. You did mention the difference between the experimental, which is the gold standard, as well as the observational. With the work that yourself, Susan, and Victor are doing in trying to merge machine learning with causality, do you think the improvement to this assumption is going to get us very close from the observational to the experimental standard as we so wish? Thank you very much.
Sure, thanks. Yeah, so there's there's a lot of different questions in there. So I don't think there's any fundamental problem kind of in dealing with heterogeneity in terms of continuous characteristics. So here in the example for the Uber drivers, it was discretized in kind of top 10%, sort of bottom 10% and the rest. But dealing with that directly with continuous measures is not all that, is conceptually not all that difficult. Kind of the computer science methodologies kind of and machine learning have made those things much easier. I didn't really talk all that much about observational studies because much of my work has been on analyzing observational studies. And I think the biggest challenge really there is in trying to validate these methods. Kind of, it's very easy to come up with models and then say, well, you know, you should use them because I say so. And in some sense, that's kind of what the eBay example was about. There was sort of, at eBay, there was this culture, okay, people have figured out how to value doing these advertising on Google, and you should trust these models. They're very complicated. We should just believe us that these are working. And it turned out they weren't working. That wasn't right. And so you need, for all these observational study methods, and that's really a big part of what Josh Angress referred to as the credibility revolution in economics. It's really about by doing the validation of these methods and showing that in some cases we can really make a strong case that they are working. We do that using these placebo analysis and other methodologies, but we build the case that these methods are working, and that's true for analysis kind of under unconfoundedness, where we make these assumptions that adjusting for observed characteristics is sufficient to make the correlations have a credible causal interpretation. But in other settings as well, we need to constantly try to validate these methods and probe them as much as we can to build the credibility for them. And that's an ongoing business, but I think we've made a huge amount of progress there.
Unfortunately, we run out of time for questions. Then we will be going to our next speakers. Thank you so much, Professor Imbens, for your presentation.